Okay, guys, so I'm going to do this problem. No calculator. And so, okay, so we've got this table. Joanna jogs along a straight path for this time interval. Okay, so for 40 minutes. Joanna's velocity is given by a differentiable function v. Now, guys, as soon as you see in these word problems, as soon as you see, or anytime actually, even in multiple choice, if you see differentiable, write down continuous and smooth, okay? In case you have to do an explanation that involves continuity. Okay, selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. So part A, use the data in the table to estimate the value of v prime of 16. Okay, so 16 is not in the table, but it is between 12 and 20. So v prime of 16, that's the rate of change of the velocity. So the rate of change of the rate of change. So that's acceleration. And so to estimate the derivative from a table, you're going to use just the average rate of change, over the interval. So yeah, so this is the slope of the secant line that you're using. So this is for part A. So we're going to estimate v prime of 16 by doing this. We're going to do v of 20 minus v of 12 over 20 minus 12. v of 20 is 240 minus 200 over 8. Okay, now you need units. So what is changing here? It is velocity. What are the units on velocity? Meters per minute. So it's meters per minute that's changing. So there's a change in meters per minute, okay? And guys, you could also say, and this is more typical, 5 meters per minute squared, okay? So that is the answer to part A. You could leave it like this though, meters per minute. Okay. Now, for the second one, let me actually try to raise this up. Okay, now for part B, using correct units, explain the meaning of the definite integral right here, the integral from 0 to 40 of the absolute value of v of t dt in the context of the problem. Well, guys, we actually just learned this. If you're up to date, this is the formula for the total distance. All right, so this is going to be the total distance traveled. Yeah, so in the context of the problem, so what's happening? Joanna's jogging at this velocity. So this is going to give us the total distance that she jogs. And you've got to use units in your explanation. Okay, and I'm going to show you how to do that. And we'll practice this units thing more. But it is the total distance in meters. Well, I'll be like this. The total distance Joanna jogs in meters. Okay, that's very important right there. In meters from t equals 0 to t equals 40 minutes. Okay, so the distance is in meters, the time is in minutes. All right, so there it is right there. B, okay, now C. Oh, actually, I need more room. No, we're not even done with B. Okay, so approximate the value of this using a right-Riemann sum with the 4 subintervals indicated in the table. So the 4 subintervals indicated are 0 to 12, 12 to 20, 20 to 24, and 24 to 40. Okay, now, guys, it's important to know, all right, so, let me think. Okay, so we're trying to find the area under this curve. This is the absolute value curve. So this is going to take, all right, so if I want the absolute value curve, so if I want to change this table to the absolute value of velocity, the only thing that would change is that output right there. Okay, that would turn positive. So because all the negative parts would flip up over the x-axis, and I actually did this wrong initially. I'll just show you what I did wrong. I went like this. I just graphed the things in the table and found the derivative, but I had to flip that one over. Okay, and I wasn't paying attention. I forgot. So what I would recommend now is that you draw, if you can't visualize it in your head and figure it out that way, then definitely draw a graph. Okay, so I'll just go like this. It does not have to be perfect. It'll just help you visualize. So there's the first point, and then we've got 12, 20, 24, and 40. And then my y values, I've got 150, 200, can't really see, 240. So I'm just getting these from the table. Oh, no, see, I'm doing it again. I'm going below. 200, all right, so then this, we'll say right here is 220. Okay, so at 0, it's 0. At 12, we go up to 200. At 20, we go up to 240. At 24 to 220. And then at 40, we go up to 150. Okay, they want us to use a right Riemann sum. All right, so for each subinterval, you're going to the right endpoint and up, and that's what's determining the height of your rectangles. Oh, shoot, my bad. And then, guys, because this is differentiable, okay, because Joanna's velocity is differentiable, it is continuous, so I need to connect these dots. Okay, so I'm connecting those dots. I forgot to do that. And then I go, and here, and there. Okay, so I'm using the right endpoint to go up to the graph from there. And then you find the areas. You do base times height, and this is you're not supposed to use your calculator for this on the AP test. So it'd be a good idea, guys, on the non-calculator problems to not use your calculator. It's 880, even for arithmetic. And then 240. Okay. And then you add all of these together. And when you do, I'm not going to show you like me adding them, but when you do, you get this. 0 to 40, absolute value, v of t, dt. You get that this is approximately meters. Okay, so that was part B. Okay, now, part C. Bob is riding his bicycle along the same path. So this is going to be part C. For t in this interval, Bob's velocity is modeled by this function, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. All right, so the acceleration is the derivative of velocity. So it's the second derivative of position. So I go b prime of t equals 3t squared minus 12t, okay? And then b prime of 5, you're just plugging 5 in, so you get 3 times 25 minus 60. 75 minus 60, you get 15, and he's got the same units, meters per minute. So this is meters per minute squared. Okay, or meters per minute per minute. I'll say, or meters per minute per minute. Okay, because it's the top here. This is what is changing. That's what is changing per minute. Okay, now part D. Okay, so part D, based on the model B from part C, find Bob's average velocity during the interval 0 to 10. So you need to know this formula. Okay, so average velocity, you need to know that it's 1 over B minus A from A to B. And guys, this formula will actually give you the average of whatever you put in here. Okay, whatever you put in here, it's going to give you the average. Okay, so I need the average, Bob's average velocity on the interval 0 to 10. So 1 over 10 minus 0, integral from 0 to 10. Now, in this case, V of t is B of t. That's Bob's velocity. And then, so this is 1 over 10. The integral from 0 to 10, t cubed minus 6t squared plus 300. Okay, now I'm going to bring this down. This is a non-calculator section, so no math 9. I'm using the fundamental theorem of calculus right now, which says you can take the area under a curve by doing the antiderivative and then plugging in these values and, you know, having subtraction between that. So antiderivative is 1/4 t to the 4th minus 2t to the 3rd plus 300t. Okay, now I'm plugging 10 in. Okay, so I plug 10 in and I get 1, 1, 2, 3, 4, 1, 2, 3. Sorry, I was just thinking of something. And then this is 2,000 plus 3,000. Okay, now, oh yeah, and then it's minus, and then you plug 0 in and you just get 0. Okay, now guys, however you want to do it, like, to figure out this inside here, but I mean, I'll just show you like how I would figure it out without a calculator. Like you could just do like old school stuff, but or like stuff that you're used to. But I just want to show you something because it does come in handy when you're dealing with a lot of digits, when you're doing arithmetic with a lot of digits. You could factor something out. Okay, so this is 10,000, this is 2,000, this is 3,000. A greatest common factor, guys, is 1,000. All right, so if I take out 1,000 from these, then I've got 10/4, right? Please be right. I think so. Yes. 10/4 minus 2 plus 3. Okay, that just makes it a lot easier for me. And then, I could multiply the 1/10 by the 1,000, and I get 100. Okay, and then here on the inside, 10/4 plus, that's plus 4/4, because this is 1. So 100 times 14/4. So this is, yeah, 1/4 of 100 is 25. So that's 25 times 14. And that is 350. 350. Now, This is, we're not finding displacement or total distance. If we were, then the units would be meters. We are finding average velocity. So the average of velocity is going to have the same units as velocity. So this is 350 meters per minute. Okay. And guys, you don't have to do the arithmetic the way that I did, but like I said, when you're dealing with a lot of digits and you're having to do things by hand, sometimes it works to factor something out, but do it however you want. Okay,